Hello, let's take a look at how and why the area formulas for kites and trapezoids are what they are and why they work. First, we look at kite. Hello everybody, quick video to show you the area formula of a kite and where it comes from. Right here we have a diagram of a kite. You can see that I have the diagonal that would go from the closer vertices to each other is labeled as A. It's just labeled on the outside of the figure. And the longer diagonal is labeled at B. It's just labeled on the outside of the figure. I'm going to go ahead and show you there. You can see A and B on the inside of the figure, and you can see that those dimensions are the same. Watch what happens as I drag this slider. We're going to see the kite kind of come apart. There you see those sides flip over, and then those triangles that that's made out of are going to move to the other side of the kite to form one single rectangle. That red rectangle that we see there is half of this blue rectangle that is created by A and B. The blue rectangle has area AB, A times B, base times height. The red rectangle is half of that. The red rectangle, which is the area of our kite, just rearranged a little bit, is half of A times B because it's half of the blue rectangle. Now let's look at trapezoids. First, I've just got a diagram of a trapezoid right here. The height is labeled, the lower base is labeled, the other base is labeled. These are labeled B sub 1 and B sub 2. We can just say B1 and B2 for short. They're different lengths, so we need different labels. Here, I've doubled the trapezoid. I've taken this trapezoid and I've copied it once here and twice here. So this new parallelogram is exactly two of these. Notice that the created sides here are now parallel as well. And my new base right here is B1 plus B2. My height still remains right here as H. We know the area formula for this parallelogram, and the area formula for this parallelogram is B1 plus B2, that longer base, times my height. But that's not the area of the trapezoid. The area of the trapezoid is exactly half of that. So it's B1 plus B2, all times H divided by 2. Sometimes folks don't like a nice big fraction like that, so they simplify this by simply saying B1 plus B2 times H divided by 2. And there's our area formula for a trapezoid. Here are 5 different methods of visualizing the trapezoid. First, we want to look at the first one that I just showed you on the previous slide. As I show the midpoint and then spin this guy around, you're seeing that trapezoid duplicated right there. And here's how the area formula works. Second method. Oops, I need to unslide that one, sorry. Okay, second method, I'm going to show 2 midpoints on both sides, and watch these little triangles. They're going to flip around, and there we have a rectangle. Here's how that area formula works. Here's the third one, just one midpoint. We're going to go from the opposite vertex of just one base, create that little triangle, and flip that guy around to make a triangle. Here's how that area formula works. Unwind that one. Here's a different way of making a parallelogram. I'm connecting midpoint to midpoint across that whole mid segment and flipping that half upside down. Here's how that area formula works. And lastly, this one's kind of the most complicated. I'm going opposite vertex to create 2 different triangles. Each of them have the same height, and here's how we can simplify this area formula.